Okay, so it's Tuesday, November 5th. Um, we're second day of all cosines. I need for you to work number 2. All right, I need you to take what we started yesterday and carry it forward. Let's see what you can do. All right, we'll give you 2 minutes to start. Go. Now, what are we looking at, guys? Hey, what are we looking at? What scenario are we looking at, guys? Side angle side. Why is that important to identify that? You know which one house of it. Cynthia, how do you know that you're to use law of cosines with this?
Because the law of cosine, you use side, 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 or side, side. And the law of sine, you just use ASS.
ASS, A, angle, side, angle, and what's the third?
Side angle side.
No. Angle, side. Remember, law of sines deals with 2 angles, right? Except for the donkey theorem, right? Yeah. All right. So if we're looking at this, it's good to identify who the sides are that we're having play. So we have 24 for A. We have 23, and then for the angle we have 69, right? Do we have a bridge?
No.
What do I mean by a bridge? Say it again, Cynthia.
A pair that connects from each side.
Say it again.
A pair that connects from each side.
There you go. Y'all hear that? A pair that you connect from each side, right? All right. So looking at this, doing the table is a really good strategy to make sure that you've got all your information together, right? From here, where did you go? What was the first thing you did? Solve for who? B, side B. And in doing that, we have what? B squared equals A squared plus B squared minus what? 2AB cosine of what? B? Where can you and were you able to write the equation without referencing back to it? Is 2AC? Oh, it is, didn't I? I used it, didn't I? Good catch. All right. If you'll notice, the square terms here are what negative 2 has been multiplied. The side that you're solving for is the angle that's referenced, right? So there is a pattern in this. And on your quiz, you'll be able to use, you'll have all the side formulas as well as the angle formulas right there. Okay, so you have all your reference material that you need. You just got to know how to utilize it. All right. So when you evaluate this, we've got what? 24 squared plus 23 squared cosine of what? All right. So what does that all equate to? 709.36. Do y'all concur? Yes? April, J, TJ, y'all okay over there? Y'all agree with that answer that you got thus far? Yes? Anybody disagree with that? All right. This is a checkpoint for me. Okay? The reason that's a checkpoint is it tells me where your mistake was. Was it in plugging it in to evaluate it or after you've evaluated it? Now we're going to take the square root of 709.36. What do you get? 26 point what?
63.
63. All right. Any questions on that? Anybody? Y'all good? Okay. How did you go about finding angle A and angle C, or angle C? Law of sines? How many of you raise your hand if you use law of sines from here? Huh? For one? Yeah, you only have to find it once, right? Once you use that, then it's just add those two subtract one. Anybody use the law of cosines? Anybody? Okay, so we won't work it both ways. Reason being is when we're given side, we are all in the angles up there, right? So let's just go ahead and get started. All right, where's my bridge? B. What do you have to be mindful about this bridge if you use law of sines? Huh? No. Yeah, you have to do the inverse, but what do you have to be mindful of?
You gotta make sure that 69 is the largest angle.
69 better be the largest angle, right? Man, that means all of them should be right around what? 50 to 60, right? Does that make sense? Yeah. How do you know that, Sam? 100, okay. But I don't see but one angle, so how did you pull that out then? You just did it.
All the signs are like close to them.
Say it again, David.
All the signs are close to them.
All the sides are close in what? Numbers. So is there a relationship between the sides and the angles? Yes or no? Yes, there is. We learned that back in geometry, right? All right. So which one do you want? How many of you saw for A? How many of you saw for A? Raise your hand. Okay, C, raise your hand. Okay, A's have it. Sorry. So sine A over 24 equals sine of 69 over 26.63, right? Now, the 24 here, what do we do with it? Move it up to the top. Do half of your cross product, right? And since we're dealing with an angle, then we'll need to take the inverse of the sine to get rid of that portion of it, right? So this is what you should have as a calculation. That would be 24 sine of 69 over 26.63, right? So that would be angle A, and what does angle A equate to? 57 point what? 29. Anybody get anything different? David, what'd you get?
I got 57.4. I might have typed it.
57.4.
Yeah, I might have typed it wrong.
57.26. You did C first and found A. All right. So if you do C first and find A, and we're going to two decimal places, you're going to probably be off on the hundreds, right? Anytime you round off, you're introducing error. So even on the simplest thing of adding two things, subtracting from 180, you're going to come up with a little bit difference with the value of the hundred place, right? Yeah? How could we fix that? Yeah. No. We can buy a lottery ticket and never get the same number from that. So how could we fix, no matter what you're solving for, you'd still get the same answers if you rounded off to 2 in your final answer? Look at precision. Yes. The more decimal places, the more precise. If we were in a college setting, normally what I tell my kids, no less than 4 decimal places in your calculations. Okay? I really like 5. Give me a handful, right? 5. Now, your final answer, you can round it to, but you that way it would ensure that you are the same. Yes.
So would you like us to run, or like would you like that at our calculations to like add on that?
For these type calculations, you're just gonna have you'll see maybe 1 or 2 hundredths difference. Now, if we were talking about exponentials, oh yeah, that can really make a difference. We get logs and exponentials. We will go out forward. So in some calculations, actually, it changed it as much as 500 to 700 difference, just based off the basis used. So it really depends on what the application for the person. All right, so what'd you get for C? Just curious on C, right? 53.71? Okay. 71, okay. She got 74. How many hundreds are we off? About 3, right? So Jane already said she saw for C first, then went for what? A, right? So we're not gonna, we'll be okay. We're not gonna worry about 300 so.
See, I saw, you made me confused because I saw for using the law sign.
We're going to.
And I done that, and I saw for C first, that's why I thought I did it wrong, because y'all know.
And you got C using the angle one? Okay. All right, so here's what I want to do. Any questions on what we got thus far? Anybody?
What?
Hey, look at me. Stop, drop, look. Any questions about what we've done so far? Anybody? You have an option. You can use law signs or you can use law cosines when you're second stuff, but you definitely got to use law signs first, right? Okay? Now, we're going to rework it, but we're going to rework it with, and I highly suggest you doing this because this leads in perfectly into the next scenario, which is side, side, side. Which one you want to solve for? We're going to use the angles or the equations on the left on the board there. And you need to make sure you have those in your notes. So which one you going to do? You want C? All right, we'll do C. So we'll go cosine of -1, that is C squared, so that's 23 squared, minus 24 squared, minus 26.63 squared, all over what? -2 times,
24.
times 26.63, right? All right. Now, what do you need to do and ensure that you have the least opportunity to make an error here? What's the thing we need to press on a calculator? No. Well, no.
Make sure you have it in your degree.
Yeah, you're going to make sure you have it in degree, right? I think most of our calculators did change back over to degree. But what's the one thing that we're going to do? We're going to use the inverse cosine, right? So you get cosine twice. But after you get that one, how are we looking for? A fraction, but, and here's why. Order of operations, if you can make it look identical to that, order of operations will not come into play, right? Now, I will tell you this, ladies and gentlemen, the 24 squared and the 26.63 squared, I would make sure that those were in parentheses. Now, I haven't checked to verify with and without, but knowing how order of operations happens or appears in my life, I tend to, if I'm going to square anything, I'm going to make sure it's in parentheses, right? So, I'm just curious. So that's, what did we do? That's C, right?
Yeah.
Okay, so what did you get out?
I got 53.73.
53 point what?
73.
73. 77. I mean, you use more than 2 decimals on any of your calculations?
Oh, I think I put it in.
Huh? You got 26.63 makes a difference. So, okay. Anybody confused about how we did that? Anybody? Did everybody participate? Yes or no? Yes or no? Yes. Okay, so I hit cosine twice. Hit cosine twice, that gives you cosine -1, right? Now hit the n over d. That up above 7. There you go. Now, if you type that off. Now, how many of you didn't put the 24 and the 26.63 in parentheses and still squared and got the right answer? Or did you put it, did you do this? That I have in red. Did you do that, or did you just type it in the black? Okay, so, all right, so, okay, it'll work. I just needed, I had to verify whether that would make a difference. Okay? I just did it, if I want to square set, I put it in parentheses, stuff. Not knowing my calculator, I don't use that as much as I do my other one. I know if I square a number, I better have, if it's negative, but these aren't really negative numbers. You're subtracting those. Good job. Okay, any questions? Jay, y'all okay up there? Y'all good? Did you get that? Huh? Why? Have you done it with the cosine? Using the inverse? Okay, good. Okay. All right. I just want to make sure that everybody's on the same page. Now, that's sine angle side, right?
Yeah.
Yes? So what you have to make sure that you are aware of is this. Look, guys. Once you find that 26.63, you can use this equation right here to find one of these angles and then do 180 minus the sum of those, right? Or you can use law of sines. But if you use law of sines, here's what you got to make sure you understand. This bridge, this 26.63, if you've made a mistake on that, then you're carrying that mistake forward. Does that make sense? So you've got to make sure that your evaluation of that, you're confident in it, right? Okay. More so that if I were you, I'd punch it in twice, right? Just to kind of verify that my numbers are right. All right. So any questions about side angle side? Anybody? You good? Yes?
Are you ever gonna ask us to find a certain one first?
No. I'll tell you to find all of them. Now the homework may say find this one, right? A certain one, and that's on. So the homework set up either find me one or find me all or this and that, right? Yes. Yes.
How's the side equation derived? Like where did they get that equation?
What do you mean the side?
The one where it says, a squared equals b squared plus c squared minus 2b.
It comes in with Pythagorean theorem, dropping altitudes and stuff like that. Yeah. This one I'm not going to derive. But it's the c squared, a squared, b squared, all come from Pythagorean theorem. You drop in a altitude to get that. You have to have a right triangle. So we know we have to drop an altitude. So, yeah. I can find that derivation if you like.
That would be interesting.
So
Appreciate it.
send me an email and I'll link you the link.
Okay.
All right, so here we go. What is this one? How do you know it's side, side, side? All of them are outside the triangle. It's obvious, Mr. Palmer, right? Okay, now, here's the question. Young whippersnapper. Huh? Insult you, young whippersnapper? Let me do this so I can. Where else have we seen side, side, side? And what was it an indicator of? Side. Where else have we used side, side, side? And what was in the indicator of? Because this ain't our first rodeo. This rodeo was side, side, side. Heron's formula, right? For area, right? Correct? So you take any triangle, as long as you know all three sides, you find it, right? Yes? Y'all remember that? Yeah, it's there. Good. Okay, so here we go. A, B, and C. A, B, C. You know what the really cool thing is about this? We don't have to worry about the ambiguous cases, right? Yes? No? I will give you this bit of insight.
So we've got, you better label these. It would make a little bit easier for you to do it. So 24, 26, 17. Now, what do we know about the angles B and C? No, A and B. What do we know about the angles A and B? They're going to what? They're going to be close. Why? Because they're what? Numbers are close in value, right? You see what I'm talking about? You see how you know some things just by looking at that? It's like national treasure. It is. It's like you can see some things, you know some things from it, right? It's like, cool. Which one you want to solve for? For grins and giggles, we're going to solve every one of them. And then you should be okay with these types of problems. Do you understand me? If we work them 3 times, guess what? This calculation that's over here on the left, you ought to beat this. I mean, because all you're doing is twice, right? You got to at least do it twice, right? I mean, I guess you could do it once and then law of signs, but once you get this familiarity of it, it goes down quick, right? You're like, no, I don't want to. Please don't make me. I know. Goes down that. Jeez. Okay. So I'm going to start with A. What did you start with? Or have you started? You know what? I'm going to give you 2 minutes to get as much head start as you can. I'm going to work A, then I'm going to work B, and then I'm going to work C. But I need you to solve for A first. When you get done with A, start with B, then start with what? C. All right? So go. All right. Angle A. Angle A. You found a shortcut? Oh. So that's 24 squared minus 26 squared minus 17 squared all over -2 times 26 times 17. Voila. Ladies and gentlemen, what does that equal? 53.89. 63.89. Do y'all agree?
Degrees.
Oh, degrees, you're right.
Come on, man.
Everybody agree with what we got. Yay or nay?
Yes, sir.
Yes. Okay. All right. Nervous? Oh, it's okay. It's okay. It's okay. Well, we'll pray that we don't stress you out. Okay. So I got 26 squared minus 24 squared minus 17 squared over -2 times 24 times 17. Ladies and gentlemen, what does that equal? 76.61 degrees. Do y'all concur?
No. Wait, what? I got 61.53.
Check.
I was
Sure you-
66.6.
You just being facetious. Then
So how do we get?
just being picking on. Hey, all right, raise your hand if you got 76.61. All right, raise your hand if you got, what's the other answer? 61.53.
So are we supposed to do?
Oh, majority rules. Ma'am? Yeah, that's what I said. Please do them all in cosine. Because that way, we have done them 3 times, right? Then you are good enough to be able to do sine, because you have used all 3 of the formulas, right? And you've used this skill how many times? 3, right? I know, just want to go back to that. Okay, so I'm going with 76.61. Let's see if that even makes sense. Hey, it does. Because 24 is A and it's Yeah, that's good. Now, what do I know about angle C? It better be smaller than those two, right?
Yes.
Yeah, it's not -1, and that's 17 squared minus 24 squared minus 26 squared, all over -2 times 24 times 26, right? Ladies and gentlemen, what does that give? 39 what?
It was like 49 and the third one was a 9.
Yep,
So I
you agree. All right, ladies and gentlemen, how did we do on our angles? Raise your hand if you got something different. Nobody got anything different? Camille, y'all okay up there? Yeah, you got those? Yes, everybody see how we calculate those? Yes or no? Yes? Chris, you okay? You see how we did that? Yeah? Okay, guys, so listen. Any questions on this? Bless you. Any questions on this? Anybody? Everybody was able to do this 3 times and got the right answers. So here's my question. Can I ask you this? If you get comfortable enough in doing this and you already have them solved in terms of A, is there a benefit to do law of science? Yes or no?
Yeah.
You're a little bit more comfortable with law of science? Yeah? You knocked that quiz out of the park, didn't you? Yes, you did. Very proud. Now, my calculator. Oh, well, add them up. Let's see what we got.
Never mind, they are
Oh, they are. Yes, they are. Lord have mercy. Okay. How can you double check what we got is right? Add them all up, see if they equal what?
Yeah.
Whatever, right? Okay. All right. Any questions about this? Do you need another example side, side, side? Yes or no? You good now? Okay, so my question is this. What do you think about law of cosine? Easy?
It's easy, but it needs like 4 steps that you have to write down.
It's a little bit more, it's a little bit more complex for equations. It's not a nice little ratio proportions, right? Like law of sine.
But once you know, like, what if I even want to do?
That's right. Now, what do I get to use on my quiz on Fridays? Yep. These, as well as the formulas for the angles, right? And the formulas for the what? Sides, right? Now, if you choose to use law of sines, law of sines, that's on you, right? You don't understand that? I will not be providing you with the formulas for law of sines. That's something that you got to be comfortable with, right? And that should be easy by now, right? Those stuff, if you've done enough. Okay. Any questions? So tomorrow, let's set this up. We're done with today's lesson. Y'all good with that?
Yeah.
Yes?
Yeah.
Anybody need any more examples on law of cosines? No, I will put it up on the canvas. Okay, so the answer sheet for this will be up on Kansas. But, all right, so we're through with this?
Yes.
All right, this concludes our lesson.